Okay, welcome. This is kind of like a bonus lesson. I just wanted to talk about some of these things. So the first one is horizontal transformations, a warm-up we did in class. And then the next two are just practice graphing questions for the mastery question. And so the first one, like, I want to show the difference between these two because they are both horizontal transformations. The first one has a horizontal compression by a third and a shift right 9. The second one looks very similar, but it can't be the same because it's not in the same form. So indeed, it actually has to be in this form where it's factored out. So we actually divide to put the brackets in. Remember that distributive law would say this is 3x times negative, and then 3 times negative 3 is negative 9. And so this is actually a horizontal shift to the right 3 and not right 9. Okay, and so it's just something I want to make sure that you're aware of. That number has to actually be factored out. And sometimes that shows up as a negative sign that actually has to be factored out. And so it will, like you're wondering why the shift is opposite, but that negative sign would have to be factored out too if there was a negative with that 3. Some practice graphing questions. So we got the absolute value graph, and so we start off with the base points. Remember that what we're doing is we're taking the inputs -2 to 2, and we're just making them positive. State all the transformations. We got a vertical reflection and a vertical stretch by 3. We also have a horizontal stretch by 3. And we can actually multiply the x's by 3 and the y's by -3. And so the orange graph that shows up is those points. Okay. And then we've got the 2 inside, actually means a horizontal shift right 2. And so we just take every point and shift it to the right 2. And that's the shape we've got. Okay. So what I'll ask you to do is state every transformation and then show how the base points are changing. So the next one, we start with the 1 over x graph. And remember, we plug in -2 to 2, but because we can't plug in 0, we plug in -1/2 and 1/2. And that gives us our base points, and that's the predictable shape that we had, that asymptote shape. The 2, what it actually does is vertically stretch it. It's not down with the x, but it is a multiplier, and so what it does is it vertically stretches it by 2. So we can multiply all the y values by 2, which is really 2 over x, and all these values just double, and our orange points just stretch out double. Okay, and you can see that it gets pulled further away from the x-axis, just double the height. Then we've got shift left 4, means the vertical asymptotes at x equals -4. And then we got a shift down 1, which is a horizontal asymptote at -1. Okay. That's kind of rough where that is, but that's right at -1. So we plot those points. If we shift everything left 4 and down 1, that's not the best point there. But left 4, down 1. You can see what's happening. Actually, that point's fine. We're taking the orange points. I was looking at the red. So left 4, down 1, 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 and left 4, down 1. And really, like, you see how it can be confusing keeping track of left 4, down 1. But you can plot these points as if this was the new axis. Notice that this point's -2, -1. -1, -2, -1/2, -4, which is what these points are. So that's another way to do it if you've got this intermediate table of values. But certainly you're just shifting every point. So you just got to keep track of each one. Okay?